Good morning, good afternoon, good evening. It's your boy Mr. Balaji, and I'm back with another video. And in this video, we're going to be unpacking how do we actually find the equations of these straight lines. So first of all, what we need to know is this equation here, which is called the standard form of a linear graph, or a standard form of a straight line. So this is what we call the standard form, right? And another way you could say that is just the general equation of every straight line. We like to look at it like that. What does the M stand for? The M stands for gradient, the one we were calculating in the previous video. And the way we calculate that gradient is we use this formula here, which says y2 minus y1 is divided by x2 minus x1. So that's how we always calculate gradient. Then the C there, what that stands for, this stands for the y-intercept. So what does it mean? That is where the graph is going to be cutting our y-axis. So let me give you a pictorial visualization. So if this is my y-axis and this is my x-axis, and if I have a line that goes like that cuts there at 4 and cuts there at positive 3, then what is my C value? My C value in this case would be equal to 4. Where am I getting that 4? This is where this graph is cutting my y-axis. So if it cuts it at 4, that C value is equal to 4. Let me draw you another graph. If we perhaps have a graph that looks like this, then that is not a straight line. But imagine if it was, then that value there where it's negative 3, and let's say that value there is a positive 4, then what would be my C value? In this case, my C would be equal to a negative 3. I hope that makes sense. That is what the C value is. Pictorially, that's how it looks, but we're going to have to calculate it. Sometimes you can figure it out from the graph. Sometimes you do need to calculate it. So let's have a look at a couple of examples. But before we look at examples, let me give you a quick procedure of what we're going to always do when we're given these types of questions. The first thing that we need to do is we need to find gradient. We need to calculate what the gradient is. So find the gradient. I use find there, but actually we are actually calculating the gradient. The second thing that we're going to need to find is the y-intercept, that C value. And as soon as you find those three things, you can therefore find your equation. So these are the 3 steps that we're always going to follow. And yeah, so let's jump right into it and let's look at an example. Alrighty, so this question says we're given this graph here and we are asked to determine the equation of that line AB. So first thing that we always need to do is we need to first find gradient. So what is gradient? Gradient is equal to the y of 2 minus the y of 1 divided by the x of 2 minus the x of 1. So when you're given those two coordinates, you do need to label them 1 and 2. So that when we substitute into that formula, we know exactly where we're substituting, and we need to be consistent with that. So my y of 2 is this 5. That is subtracting this minus 2. That is divided by, which is going to be a 2. The x of 2 is this guy. That is subtracting a minus 7. Right? And if you plug that into your calculator, you should be getting 7 over 9. So that is a positive gradient. And yeah, we've done the first step. Then the second step then says find the C value. So what we're going to do is we're going to take our general formula of a straight line. We're going to substitute this M value that we just calculated now, which is a 7 over 9 x plus C. So all I just did was replace that M with the value of M we calculated. Then at this point, you could choose whichever coordinate. You could choose A if you want to, or you could choose B if you want to substitute for the Y and the X there so that you can solve for the C. So what I'm going to choose is I'm going to choose to use A. My X is the 2, my Y is the 5. So the 5 goes that side, and my X of 2 goes that side. So make sure when you're substituting correctly. Then this guy you could just solve, evaluate. 5 is equal to, that will be a 14 over 9. And if you take that 14 over 9 to the other side, it subtracts. And so C is technically equal to, so that C value is 31 over 9. So what does this mean? It therefore means step number 3, that my equation is y is equal to, you substitute your gradient and you substitute your C value. And there we go. And so this is our equation. And another thing you could just double check is if you put in that C value there, it gives you 3.4. So if you look at it, this point here is 3.44 and so on. So there we go. Let's try the next example. Alrighty, so for example number 2, we are instead given the intercepts that it's experiencing on the y-axis and on the x-axis. We still ask for the equation of the line. So what we need to figure out is what is actually that coordinate there. Since we are on the y-axis, the x is 0 and the y is going to be that 4 there. For this guy, since we are on the x-axis, the 3 is the number and the y is 0. So those are the coordinates of that guy. Again, what we're going to do first, we're going to find the gradient. And gradient is always y2 minus y1 over x2 minus x1. So again, you label them. This is my 1 and this is my 2. Now when I substitute, the y of 2 will be this guy. So a 0 that is subtracting a 4, and the x of 2 is a 3 that is subtracting a 0. And if you plug this in, you should get a negative 4 over 3. So that is my gradient, right? So again, I take my equation, y is equal to mx plus c, the general one. And in place of the m, I substitute that fraction there. So it will read y is equal to a negative 4 over 3x plus c. All right, so now let's solve for that c value. One thing that you can do in this question is that the c value is clearly indicated there as being equal to 4. You can clearly see it, so we don't need to calculate it. But I want to prove it to you that you can actually still calculate it. So let's keep calculating it. I'll take this coordinate of 0 and 4. Remember, at this point, you can choose whichever coordinate. I'll take the 0 and the 4. Remember, this is the x and this is the y. So the 4 goes that side, negative 4 over 3, and the 0 goes that side. And you will see that this is times by 0, so it just gives you 0. And so c is equal to that 4 that we already can see from the diagram. This is just us proving that it is that, or actually calculating it. And so therefore we can conclude that our graph is negative y minus 4 over 3 with the x plus a 4. And there we go. This is our final equation. You need to always represent it in this form. And there we go. So this is how you go about solving equations. Yeah, you just need to understand what standard form is and how do you go about solving these equations. As just one little caveat to this, I just want to talk you through what are the equations of vertical and horizontal lines. Let's look at that in the next example. Alrighty, so we're given this vertical line there, and one thing I do want to speak you through is if we were trying to find the gradient of this line, it would still be y2 minus y1 over x2 minus x1. But I want you to understand is that if we have a point there, let's call this point A, which would have a 2 and a 0. If we had another point down here, let's call that one B, which will be a negative, which will still be a 2, but with a negative 3. So those are the coordinates of A and B. And if I were to use these two to actually solve for the gradient, I would then notice that actually, since the x values do not actually change, then the difference of these two x values would give me a 0 at the denominator. And anything that is divided by 0 is called undefined. So what is the gradient of a vertical line? A gradient of a vertical line is actually undefined. But does that mean the vertical line does not have an equation? No. That vertical line still has an equation, and all that you need to do is wherever it's cutting my x-axis, then the equation of that line would be x is equal to that value. I hope you can see that. So I could draw you any vertical line. Let me draw another one here. There's another vertical line that cuts there at -1. Then what would be the equation of this guy? This would be x is equal to -1. So that's how you find these equations, or that's how you write these equations of vertical lines. Then similarly with horizontal line, let me draw this horizontal line that cuts there at -1. So in terms of gradient of this line, if we were to calculate the gradient, m would be equal to y2 minus y1 over x2 minus x1. But what are we noticing here? So let me take a point there as my A, which would be a 0 and a -1. Let me take another point there, which is my B, which would be a -3 and a -1. What you should be noticing here is that this x, well, rather, sorry, the y value does not change. So here at the top, we would be having a y2 minus a y1 giving me a 0 because they're the exact same value. So what are we having? We have something, a 0 divided by something. We don't know what that number is, but it will be a 0 at the top, and this will always give me a 0. So if you divide 0 with anything, you will always get a 0. So what does this mean? For horizontal lines, the gradient is 0. Right? So maybe let me make a conclusion here. For horizontal lines, the gradient is 0. But what is the equation of that horizontal line? The equation will be therefore y is equal to wherever it's cutting the y-axis. And in this case, it will be a -1. I hope you're seeing that. Again, let me just reiterate what I said about vertical lines earlier on. I said vertical lines, what they gradient is equal to, it's actually undefined. So even saying it's equal to undefined does not really make sense. It's just undefined. You can't find that gradient. You can't actually solve for it. We call it undefined. And yeah, but the equation of that line will just be x is equal to whatever point it's cutting your x-axis. The equation of the horizontal line is y is equal to wherever it's cutting your y-axis. And this should be clear to see from the picture. It shouldn't be something you need to think about. You just look at your picture. Where is it cutting? If it cuts my x-axis, x is equal to that value. If it cuts my y-axis, y is equal to that value. And on that note, I hope this makes sense. I will see you in the next video. In the next video, we will be unpacking how do we actually plot these guys. when given the equation, how do we plot them? How do we draw them on the Cartesian plane? And literally that is the reverse of what we're doing today. Today we were given the picture and we're trying to find the equation. So in the next video, we'll be given the picture, or rather the equation, and we're supposed to get to the picture. On that note, I will see you in the next video. Bye.